In this video, we're going to look at an application problem for exponential functions and graphing. So we have this problem here. A typical worker at a supermarket bakery can decorate f of t equals 10 times quantity 1 minus e to the negative 1/4 t cakes per hour after t days on the job. So the first thing we want to do is just sketch a really quick graph. You could sketch in Desmos as well, but just want you to kind of get the feel for doing quick sketches. So one thing we could do here to help us out is to distribute this 10 here. So we would have 10 minus 10e to the negative 1/4 t, and that way we can see that we have a vertical shift, so our asymptote is going to be up here at y equals 10. So then that helps us get our curve. Normally exponentials go this way, but we have a flip, so we're going to actually go the other direction. So I'm just going to quickly sketch this in here, and it would be kind of right about here. And I'll put that in Desmos as well real quick so you can see that. I'll pause, and maybe you could try it and then check. And then you can use the formula to answer these questions. You might reference the graph for the last one here, but just go ahead and try it, do it like as a classwork, and then check back. So just a quick look here, you can see the graph. We wouldn't include this domain, this line to the left, because we wouldn't have a negative value for our f of t, but you can see where that approaches the 10 for the horizontal asymptote. For this, remember in Desmos, you have to use x or y if instead of like t and f of t, just so it works out that it recognizes that. You could define some variables, I think, as well. E worked by doing the ABC here, and E is a number, it's not a variable, but it is 2.7189, so on and so forth. So that one worked for this. It recognized that as E. So now we can go back to the other part of the problem. For part B of the problem, how many cakes can a newly employed worker decorate in an hour? So that would be 0 days. So we would pop 0 into the function, and we would get 10 times 1 minus e to the negative 4th to the 0. So anything to the 0 is 1. And that would end up being 10 times 0. So that would be 0. Obviously, it would be none yet, right? So that's our point right here. And we wouldn't put negative values in like we talked about before. So think about what the domain on this is. So for C, after 8 days, how many cakes can a worker decorate in an hour? So go ahead and pop 8 in there for T, and then check back. So the answer I got for this one, I just crunched it in my calculator, was 8.65. So the worker can decorate about 8 cakes per hour. That's what the f of t represents. So I rounded down, even though it's 0.65, because it's not quite 9 cakes, it was only 8 whole cakes. Okay, so for D, how many cakes can a very experienced worker decorate in an hour? And we can see from our little graph that we're approaching 10 cakes, but we never quite get there. So even someone who's been doing it for a long time, it would be almost 10 cakes. So we would say 9 full cakes, and you can just, use your graph to help you with that, because we have this asymptote here. All right, so that's it for the cake problem. I hope that helped you get through that. So let me know if you have any questions. Have a great day.